So now that we've seen how to implement a stack, we could start to take a look at some practice problems that involve using a stack to solve. The first problem that we're going to take a look at is a really classic problem in computer science, which is the balanced bracket problem. In the balanced bracket problem, you're given a string of characters that contains various different opening and closing brackets. So say these round brackets, these square brackets, and the brace brackets. Your goal is to output true if the brackets are balanced and false otherwise. So let's talk a little bit about what that means. What is a string with balanced brackets? It would have three main properties to it. The first is that every opening bracket is closed by a closing bracket of the same type. So for example, this string here would be valid because every opening bracket has a corresponding closing bracket. Similarly, this string would be valid. Every opening bracket has a closing bracket. But for example, this string would not be valid, right? This string is invalid because not every opening bracket has a closing bracket. Just one of them does. This one does not have a closing bracket for it, so we would consider this to be invalid. So that's the first property. Every opening bracket has a corresponding closing bracket. The second is that open brackets must close in the same order. So what I mean by that is if I have various different opening brackets, they need to be closed in the same order. So the last opening bracket we saw should be the first closing bracket we see. So in this case, we see a square opening bracket last, and then when we get to the first closing bracket, it's also a square closing bracket. So this would be valid, right? But for example, if I had something that looked like this would not be valid because the first opening, or the last opening bracket we saw is this square one, but the first closing bracket we see is a round one. So these two don't match each other, which would make this invalid. So that's the second property we have, is that every opening bracket needs to close in the same order. Now the final thing is that every closing bracket must have a corresponding open bracket of the same type. And similarly, every opening bracket must have a closing bracket, right? So generally what I mean by that is if we have something that looks like this, for instance, this is invalid. It's invalid because there are two closing brackets, but only one opening bracket, right? So that wouldn't be a valid example of a string. So keeping this in mind, this seems like a lot of different rules for us to have. However, the actual process for solving this problem isn't really too complicated using a stack. With a stack, what we could do is we could keep track of all of the opening brackets that we've seen. And because a stack stores things in last in, first out format, what's going to happen is the most recent bracket we saw would be at the top of the stack. So what happens is when we reach a closing bracket, we simply compare it to the top of the stack. If they match each other, then the string is still valid. If they don't match each other, then the string must not be valid. That's really the main idea of what we're going to have for our iteration. There'll be a few other small things that we'll do to account for the other rules as we go through. That's really the main idea of what we're working with. So let's take a look at the implementation. I've imported a stack. You can use either your array-based or node-based stack. Doesn't really matter. It's going to be the same thing no matter what. What we'll do is we'll create this function isValid, which will have a value s provided to it, which will be the string that we are trying to iterate. I'm going to create an opening stack, which will be my opening brackets. I'm going to have a variable called valid, which will track if the string is valid. We'll start it off as true. Then we'll have I equals 0, which will be used for iteration through the string. And we're going to do this while valid and I is less than the length of the string. For these iterations, what we're going to do is we're going to start by taking a look and seeing if the string that we're currently at is an opening bracket. So if it's an opening round bracket or if it's equal to an opening square bracket, right? Or if it's equal to an opening brace bracket, right? So if we have either of these three things, then what I'm going to do is I'm going to place them on my opening stack. So I'm going to push those on to the stack. So if we see an opening bracket, we push it onto the stack. Otherwise, if we see a closing bracket, we're going to do something slightly different. So if we see any of our closing brackets, right, just get these out here, then what we're going to do is we're first going to check to see if the opening stack size is greater than 0. If it's not greater than 0, it means that we see a closing bracket and there's no opening bracket to correspond with it. If that happens, this string is not valid, right? So I'll just put that in now. So if we see a closing bracket, but there's no corresponding opening bracket, that means that it's invalid, okay? Now, if we do see an opening bracket, if there are opening brackets in the stack, we just need to check to see if it's the right kind. So if the current value that we're at is a closing round bracket, we're going to check to see if the opening stack's pop is also the same. So if it's not an actual round bracket, then what ends up happening is the string is not valid, right? So if we see a round closing bracket but not a round opening bracket, then the string must not be valid since the last opening bracket that we saw doesn't match the closing bracket, right? And we're going to do this for every type of bracket. So I'm just going to go ahead and copy and paste it because it's going to be a bit tedious to see me typing it out every time otherwise, right? So just copy and paste these each. There we go. Just like that. So that is the idea of how these are going to be set up. Now, final piece here is that inside of the iteration, we need to increment I by 1, right? So that's something that we need to do each time, of course, to iterate through our string. Now, so far, it looks like we've covered pretty much all of our rules. So this rule is checking to see if every single opening bracket has a corresponding closing bracket, while also that every closing bracket has a corresponding opening bracket, right? This rule here is checking to see if, the brackets are matching up with each other. But actually, the final thing that we need to do that we haven't done yet is just verify that every opening bracket has a closing bracket to it. So this one was checking to see if every closing bracket has an opening bracket, but we haven't done the opposite. The way that we check the opposite is basically at the end of the iteration, we say if the opening stack dot size is greater than 0. What that would mean is that we went through the whole iteration and we didn't find a closing bracket for every opening bracket, right? If that happens, then valid is going to be false. And then at the end, we just return valid and we're done. So let's give this a test out, right? Let's go ahead and try this. So what we're going to do is we're going to call this function isValid. I'm going to call it with a simple string that should work as true. So let's run that. And we'll see here that we end up with an error with the pop operation. Let's just take a look here and see if we're able to resolve this. I think it's actually just because I had some code still in here from our testing. Yeah, that is what happened, probably. So let's just get rid of that here for a second. Let's just run this here. There we go. Now we get the value of true as a result. So you see that the valid is true because every opening bracket has a corresponding closing bracket. If I get rid of one of those brackets, we now get false, right? If I change it to a different kind of bracket, we now get false. So you can see that this looks to work pretty well for the inputs that we have here, and you could try different inputs and test it out more as well. Final question here, what is the time complexity of this algorithm? Well, in the worst case, it's O(n), where n is the size of the string that we need to iterate. This one actually has a best case, right? And the best case for this is actually constant time. So the best case is going to be the case where basically the very first thing that we see makes the string invalid. So basically we see an opening bracket, and then the next iteration we don't see the matching closing bracket, or we immediately see a closing bracket with no matching opening bracket, right? There's a few different cases where we would exit pretty much immediately. In those cases, we have a constant time for our operations. So this is just one example of a way that we can use a stack, right? You can see that this works really nicely because we need to remember the last thing that we saw, essentially, right? The last opening bracket that was seen. The stack gives us a really clean way to be able to do that and to access it very quickly. So that's everything for this video. Thanks so much for watching, and I'll see you in the next video.